Okay guys, so let's start our next chapter. This chapter is about trigonometry. We started this chapter yesterday, but I will review it and then we will solve problems based on this. Okay, the first thing that you need to know is the difference in different triangles, and this is what we did actually yesterday. You will see two different types of triangles. One type will be like this, and the other type will be like this. What's the difference between these two triangles? Triangles. One of them is
Right angle.
Yeah, this one is right angle because this angle is 90 degree. So this type of triangle is the right angle triangle. And what is this? Non-right angle triangle, you can say. This is just a general triangle. There are different types. This one is called isosceles triangle because this has got these two sides equal to each other. But for our purpose, we will just say that this is a non-right angle triangle. A non-right angle triangle. The formulas that you can apply to right angle triangles cannot be applied to these triangles. There are some general formulas that you can apply to both of them, but those formulas that are specifically designed for right angle triangles, they cannot be applied to these triangles. So you need to make sure that you know that which formula is good for right angle and which is not. Right? If you got a general formula, that can be applied to both of them. But if you got a formula that is only written for the right angle triangle, you cannot apply that formula to this triangle. Right? The first set of formulas that we have to do is for right angle triangles. And those three formulas we did yesterday, I'll rewrite them. You need to understand three t ratios, and they are called sine, cos, and tan. Together they are called t ratios. T ratios means trig ratios. So these are different t ratios. The first one is sine, and sine cannot be written like this. It should always be written with an angle theta. You can use different letters. You can use A, B, C, D, whatever for this angle. But whatever is written after sine is always an angle. So this theta is an angle, right? Sine theta is one t ratio, cos theta is another t ratio, and tan theta is another t ratio. These are three basic t ratios that we study in trigonometry. And for a right angle triangle, this is how they are defined. The sine t ratio, sine theta, is defined as opposite divided by hypotenuse. Sine theta is always equal to opposite divided by hypotenuse. Now you will wonder, what is this opposite and what is hypotenuse? For this triangle, when we say that we are going to write the t ratios of an angle theta, where is that theta in this triangle?
Opposite the angle.
Which angle? Is it this angle? This is also an angle. You know that there are three angles in this triangle. That is an angle, this one is an angle, this is an angle. So which angle is this theta? Is this 90 degree?
Yeah.
No.
No.
No. We never write any t ratios for a 90 degree when we write them in this way. Right? T ratios for a right angle triangle are never written for the right angle. They are always written for one of these two. It can be any of them. It can be this, it can be this. Let us say that this is our angle theta. So for this angle theta, what is opposite and what is hypotenuse? You know that hypotenuse is always the longest side of the triangle. You can tell this side just by looking at it. You know that this is the longest side. So this one has to be the hypotenuse, this side. Now the other two sides, the base and the perpendicular, which one is opposite? Is this opposite?
No.
Is this opposite?
Yeah.
Yes, this side is opposite. But how do you know that this side is opposite? How do you know that? Why is this side not opposite? What's the reason?
It's not across from it.
Across from what?
The angle.
The angle, yes. You put yourself here. Let us say you're standing here looking towards the triangle. Which side is in front of you? That side, right? That's why this side is called opposite, because this is opposite this angle, right? And the side that is right next to you, that is just besides you, that side is called the adjacent. So this side is adjacent for this angle, and that side is opposite for this angle. The longest side is always the hypotenuse. So that if you want to define sine of this angle, sine theta, that will be the length of this side opposite divided by the length of this side hypotenuse. Cos theta is defined as adjacent divided by hypotenuse. So if you want to find cos of this angle, cos theta, that will be this side adjacent divided by this side hypotenuse. And similarly, the third T ratio, tan theta, is defined as opposite divided by adjacent. Now for this angle, you want to find tan of this angle. So this is opposite, this is adjacent. That means this length divided by this length will be tan of this angle. But what if I switch this angle? If I make this angle theta, will you still use the same thing? No, that will change everything. Let us see how. So let us say that for the same triangle, this is my same triangle, and this is the right angle, 90 degree. This is how we show the right angle. It's always shown as a square in the corner. That means this angle is 90 degree. For these angles, we show a curve like this. We don't show a square. For 90 degree angle, it's shown as a square. So for this one, I want to use this angle as my theta. This one. Or let us say we want to change the name. Let's say this angle is beta. You can name it anything. It can be theta, beta, whatever. A, B, C, doesn't matter. So if you name this angle as beta, then what will be the formulas? First of all, what will be sine beta?
Opposite over.
The formula is still the same. It's still opposite over hypotenuse. The formula doesn't change. But which side will be opposite now? For this angle, put yourself here. You are standing at this corner and you are looking towards the triangle. Which side is in front of you?
Bottom.
The bottom side. So that side is your opposite now. The longest side is always the hypotenuse. The third side will be adjacent. See how these things changed? Hypotenuse doesn't change, it stays the same. But the adjacent now became opposite, and opposite now became adjacent. This happened because we changed the angle. In this triangle, we were finding the t ratios of this angle. Now we are finding the t ratios of this angle. That changes everything. The formulas won't change, they will stay the same, but the sides will change, right? So if I want to write these formulas, they will still be the same. Cos beta will be adjacent over hypotenuse, and tan beta is opposite over adjacent. Okay, now let's say that we define their lengths as, let's say this length is defined as A, small a, this length is defined as B, and this length is defined as C. We are defining their lengths. The length from this corner to that corner is A. The length from this corner to that corner is B, and from this corner to this corner is C. Same for this. This one is A, this one is B, this one is C. So how will you write these things now? For this particular case, sine theta, because it's opposite over hypotenuse, what is your opposite? It's B, right? And then your hypotenuse is C. So this will be B over C. But if you write sine of beta, the formula is still the same. It's opposite over hypotenuse. But what is your opposite here? It's A. And your hypotenuse is still C. So this is A over C. So that's how the things change. Right? For sine theta, the ratio came out to be B over C. But for sine beta, it came out to be A over C. The reason is our adjacent and opposite switched, because we changed the angle from this to that. So how you solve the problems? You just remember these formulas, just these three formulas. And then you will put yourself at that angle, the angle that you are talking about, and then see which side is in front of you. That becomes the opposite. The other side is adjacent. And then you put in the values. Okay, let's look at some examples. The first example on page 257. And this example is calculate the value of x. You have to find x. Let me write this thing first. This call. Because we are going to use them again and again, so I'll write them down here. Sine theta, cos theta, and tan theta. This is opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Well, there is a way to remember this. I showed you that method yesterday. This is how you remember these formulas. You can remember this thing. So, ka, toa. So, ka, toa. And then you put equal sign and then dividing sign here. This will give you sine is equal to opposite over hypotenuse, same as that. This will give you cos is equal to adjacent over hypotenuse, same as this. And this gives you tan is equal to opposite over adjacent, same as this. So if you forget, you can use this thing to remember. So ka tua. Okay, so the first example, 1a, this one is on page 257. Calculate the value of x when the triangle is given. This is the triangle given. And this angle is given to be 90 degrees. This side is x. And this side is given as 204.9 centimeter. And this angle is given as 67 degrees. You have to find x, this one. Okay, now because we can't find t ratios for 90-degree angle, you will just ignore that angle. You know this angle, you use this angle to find hypotenuse. The side in front of you, in front of 90-degree angle, is always the hypotenuse, the longest side. If this is the 90-degree angle, you stand here and look towards the opposite side. That is the longest side of this triangle, which is hypotenuse. So you know that this is hypotenuse. The side in front of 90-degree angle is the hypotenuse, the longest side. That's how you find the hypotenuse. Now, because this is the angle that is given, and that is what we will use in these thetas. Our theta is 67 degree. So if you now put yourself here, you stand at this corner and look towards the triangle, which side is opposite you? 204.9 centimeter. So what is that side? Is that adjacent or opposite?
Opposite.
Opposite. This is opposite. So this side is your opposite. And then what will be x? That is your adjacent side, right? So this will be your adjacent side. So this is always the first step to do. You have to figure out in a triangle that which side is hypotenuse, which is opposite, and which is adjacent. Opposite and adjacent are found by putting yourself at the corner of the angle, theta, and hypotenuse is found by looking at the 90 degree. Side opposite to 90 degree is always hypotenuse, and side opposite to theta is called opposite. The other side is called adjacent. So once you know these three sides, then you can use one of these three formulas to find the unknown length. Okay, now which one will you use? Is hypotenuse known to you? Do you know what is hypotenuse? No, it's not given. The side that is given is opposite. Right? That's what is given. And what you want to find is adjacent. So these two things should be involved in your formula. You will use a formula that has opposite and adjacent involved in it. What is that formula that has opposite and adjacent? Tan theta. So you will use this formula, right? So you write this formula. Tan theta is equal to opposite over adjacent. Write down this formula first, and then put in the values. What is your theta? The angle. 67 degrees. So this will be written as tan 67 degrees is equal to, opposite is 204.9 divided by adjacent is x. That's what you have to find. Right? Now, because this is our unknown, this x must be here at the front. Whenever you see something like this, you have a number written here and then a fraction written on that side. Put this in your head. You can always switch these two numbers. You can switch x with that. x can come at the front and this everything will go underneath. You can always switch the top number here with the bottom number there, right? So when you switch them, you get this. X is equal to 204.9 divided by tan 67 degrees. I switched this and this. The other way to understand it, like this. If you multiply both sides with x, multiply both sides with x. If you multiply both sides of this with x, this will become x times tan 67 degrees is equal to 204.9 over x times x. See, I multiplied with x on both sides. This is what I did. I multiplied this expression with x on both sides. Now this way you can cancel that x out. Right? And then it leaves you with x times tan 67 degrees is equal to 204.9. And then you divide both sides by 67, tan 67. Divide both sides by tan 67 degrees. And when you do so, this will give you, I'll write it here, x times tan 67 is equal to 204.9, and then you divide both sides by tan 67. So what you can do now? You can cancel tan 67 here. And that leaves you with x is equal to 204.9 over tan 67 degrees. This is the same thing that we had got by switching this. So instead of going through all these steps, I would prefer switching these two numbers, because when you switch x and tan 67, that's what you got, right? X comes at the front like this, and tan 67 goes in the bottom there like this. So I would prefer using this shortcut method. Instead of doing all these steps, just do this. Switch x and tan 67. And that gives you x is equal to 204.9 over tan 67. Now you use your calculator to solve this. What is 204.9 divided by tan 67?
$86.9.
86.9?
Yeah.
86.9 centimeter. You must write the units centimeter, because this length was in centimeter, this length will also be in centimeters. That's your answer. So that's how you find the unknown value using one of these formulas. But remember, you can apply these formulas only to a right angle triangle. One of the angles must be 90 degree in this triangle to use these three formulas. If it's a triangle that has no angle equal to 90 degree, you can't use these formulas.
How do you calculate that 204.9 divided by 1067?
It depends on your calculator. What type of calculator do you have?
When I press divide and then put tan, it just
Oh, that, well, here you will have to do it in 2 steps. You will first enter 67 and then find its tan. That is tan 67, right? You will have to write it down on your notebook. Maybe you can write down 4 digits, 4 decimal places. 3558. And then start off with that number 204.9. 204.9, and then divide by that number. Which is same as 86.9 centimeters. Okay, let's look at another example, 1b. And in this, you are going to find x again, but x is not a side now, it's an angle. So this is the triangle. This angle is 90 degrees, so this is a right angle triangle. If this is 90 degree, which side is hypotenuse? Opposite to this, right? This is hypotenuse. And hypotenuse is given, this side is given as 17.8 centimeters. This side is given. The base is also given 15.2 centimeter. And the angle is not given. This is given as x. You have to find the angle. In the previous problem, we had to find the length of the side. Now we have to find the angle. You can find the angle using the same formulas, these ones. Let's see how. First of all, if this is your angle that we are talking about and you put yourself at this corner and look towards the triangle, which side will be opposite? This one? This is the opposite. If you are standing here looking towards the triangle, this is the opposite. And what is this side then?
Adjacent.
Yes, this is adjacent. Is opposite given? No, it's not given. So which 2 sides are known? Hypotenuse and adjacent. Which formula uses these 2 sides? Hypotenuse and adjacent. Is it sine, cos or tan? Cos, right? Because this is using adjacent and hypotenuse. And that's what we know, adjacent and hypotenuse. So write down the formula for cos theta. Cos theta is adjacent divided by hypotenuse. And then enter the values. Whatever you know, just enter that into this formula. If you don't know the value of theta, you still put x for that, because that's what we have to find, right? So this formula becomes cos x is equal to, adjacent is 15.2 centimeter and hypotenuse is 17.8 centimeter. Stephanie, for these kind of problems, I would suggest you use a different calculator, because it's not a problem, but it will be much easier for you if you have a calculator that enters everything the way we write it on the board. Your calculator does it indirectly, right? You should have a calculator that enters everything the way you write it down. I have one if you want to try this now. And you can buy a similar one. Okay, so what is 15.2 over 17.8?
31.4.
15.2 over 17.8.
31.3. Or
Oh.
31.
0.85.
Are you giving me the final answer for x?
Yeah.
No, I'm just talking about this division.
Oh,
15.2 over 17.8. Use 0. What?
8. 0.85.
85. That's it?
Yeah.
39.
39, 32, 58.
Oh, so what comes after 5? 3?
Yeah, 39.
Okay, then we can leave it as 0.85. Or maybe you can write it as 0.854. Because after 3 you have 9, so you can write it as 0.854. So if cos x is 0.854, how can you find x? How will you find this x? Okay, this is what you do. X is equal to cos inverse 0.854. Remember that when this cos goes to other side, it becomes inverse. So if cos x is given and you want to find x, this is what you do. You send cos to the other side, it becomes inverse, and then you find cos inverse 0.854. There is a button on your calculator to do that. Normally you will see this by second function. Okay. You see those yellow ones? Sine inverse, cos inverse. See that? So you first press the second function button, and then that is your cos inverse. You will see that here. And then you enter that number, 0.854. So what is this? X is equal to
31.35.
31.35 what? What is x? Is it centimeters, kilometers, degrees, what?
centimeters.
Sorry?
Degree.
Sorry?
Centimeters.
X is an angle, it's not a length.
Oh, what are you asking?
What is the unit for x?
Opposite? Oh, no, that's.
Degree.
Degrees. Degrees. The unit for angle is degrees. So that will be 31.35 degree. You put a little 0 at the top of this number. That is called degree. Degree is the unit for angle. Angles are measured in degrees. The length is measured in centimeters, meters. Angle is measured in degrees, right? Degree or radian. There are two units. Sometimes we use radians as well, but in all these problems that you will see, you will always have degrees for angle. So that's how you find the angle, using the inverse function, cos inverse, sine inverse, tan inverse, like that. Okay, now I want you to try build your skills problems. Don't do any assignment right now. Just do these build your skills problems. I want you to do 1A. Please note it down. 1A. And I want you to do 2A. Just 1A and 2A. So you should do it right now. And I'm giving you about 15 minutes to get them done.